Okay, on this problem we are asked to solve this system. This system is a 3 by 3 system, meaning there are 3 equations and also 3 variables, x, y, and z. Now, we should be comfortable solving a 2 by 2 system, 2 equations and 2 unknowns, and commonly that is done by elimination or substitution. However, with the 3 by 3 system, we need to do a few more steps to solve. Now, first off, not never, but very rarely have I ever added 3 equations together at the same time. It's very hard to track the goal of this process, which is to eliminate variables. Now I'm going to call this row 1, row 2, and row 3. Now, by adding rows together, we can eliminate a variable. So for example, notice if I add row 1 and row 2 together, and I actually want to write a little script here, row 1 plus row 2. And with addition, I would normally do this in my head, but that won't help you much to see the steps. There we go. 2x minus 3y minus z equals 17. If I add these together, what happens is the z terms eliminate. That's what we want to have happen. Somehow we want to eliminate variables. But we don't just want to start eliminating any variables. We want to eliminate one variable twice. So we have 7x minus y equals 6. I'm going to call this row 4. Okay, so we have 7x minus y equals 6. We have achieved an equation with no z. We need another equation with no z. So once you've determined what you want to eliminate, in this case I took advantage of an easy situation, adding row 1 and row 2 together to eliminate a z, I now have to do that a second time, eliminate a z a second time. So for example, if I multiplied row 2 by 2 everywhere, all the way through, I would get a minus 2z. That would add nicely with row 3 to eliminate the z. So I want minus, let's see, just 2 row 2 plus row 3. Now 2 row 2, carefully distributing 2 all the way through row 2, the numbers will be 4x minus 6y minus 2z equals 34. So we write that down. Oh, what happened? Touched it. Okay, here we go. 4x minus 6y minus 2z equals 34. And row 3 is 7x plus y plus 2z equals negative 4. When we add these together, there it is again. So as you are doing this process, I want you to see that you've eliminated, whether it's z, y, or x, that's really up to you, but you've eliminated that variable twice. Those are your first 2 steps in solving a 3 by 3 system. This results in 11x minus 5y equals 30. That's going to be row 5. All right, we're doing great. We are down to 2 equations with x's and y's. Now, in taking a look at these 2 equations, we need to eliminate something out of these 2 equations. I see a y, a minus y, and a minus 5y. So if I were to do minus 5 times the row 4 and plus the row 5, look what would happen. So first off, let's distribute the minus 5 through row 4. That gives us negative 35x plus 5y equals negative 30. Make sure you're distributing the negative 5 all the way through. And plus row 5, so row 5 is not changed, 11x minus 5y equals 30. When we add these together, notice I have succeeded in getting the y's to eliminate. That's the goal of this whole process. You start by eliminating one variable, in this case z, twice. That gets you 2 equations with no z's. Then eliminate something else. We are down to negative 24x equals, and negative 30 plus 30 is 0. If I divide by negative 24, I get x equals 0. That's the x value that solves the system. Now, that's not necessarily enough for us to have the full answer, because the full answer to these equations is a ordered triplet in x, y, and z. So now what we get to do is we get to take the x that we just found and go back to one of the equations that we worked with previously, the row 4 or 5. I'm going to plug it into row 4. So our row 4 equation would be 7x, but that's 7 times 0. Minus y equals 6. So that's gone. Minus y equals 6. That leads us to y equals negative 6. You can see that by just dividing by negative 1 on both sides, if you'd like. Great. Now we have y and x. We're missing z. Now z happens in the first 3 equations. Sometimes not in all 3 of them, but somewhere in those 3. In this case, all 3 of them. The nicest looking z happens in row 1. So I want to work with row 1. So row 1 is 5x, but that's 5 times 0. Plus 2y, but that's 2 times negative 6. Plus z equals negative 11. And reducing this down, that is negative 12 plus z equals negative 11. And if I add the 12 to both sides, it gives me z equals 1. So our solution is 0, comma, negative 6, comma, 1, in order x, comma, y, comma, z. This is a point in 3 dimensions, and this point is on each of these planes. But you can also consider that this is an ordered triplet, or ordered triple, and this ordered triple satisfies each of these equations. Now, in another video, I demonstrated how you can check a solution, and basically you have to plug in each x, y, and z into each equation and make sure that it works on all 3. I hope this has helped.